So let's do an example. And what example should we do? Hey, we got the credit card object. All right, let's do the credit card object. Let's create the credit card class. And luckily for you, I have a code file all ready to go. So I'm gonna keep this on this side of the screen as much as I'm gonna keep it on about half of the screen as much as possible. But I will occasionally need to move it around. Okay. So let's start here. How do we define our class? Well, if you recall, class is the keyword, and the nice thing about whatever IDE you're using is most modern IDEs will highlight, and so you know that you're doing something right there, right? And then we're going to need the name of our class. Well, what's the name of our class? How do we know? Well, it says so right here. Okay. Remember, you're going to be given specifications. This specification can be things like interface. It can include structure. It can include behavior. As a rule, you should be trying to design your code to match your specification as best as possible. Okay. Underperforming, as in giving people something that is less than the specification, is never a good thing. But I will tell you, frequently, giving people something that is more than the specification, also frequently a bad thing. And the reason is, you are being given a design. That design is part of a larger aspect of design. If you are giving them more than what they ask for, that might break the design. So giving them a little bit more is probably okay. But if you are deviating too far from the specification, then you might want to have a quick conversation with, whoever the architect is, or the project lead is, or whoever, your mentor on a job is, and say, hey, looking at this credit card object, I want to put in a few extra checks for robustness. Is that appropriate in this case? Never hurts to ask the question. And as you go, especially in different places, right? Different people will have different styles and different approaches, and you'll learn how people do things and what the standards are. So, but it doesn't hurt to ask, especially early on. Okay. We have our class. What's the first thing that we need to define? Constructor. So, constructor is a method. First word is def. What's the name of our constructor? Well, it's always dunder init. Right? And then parentheses. Well, what goes inside those parentheses? Well, always, always, always self. Now, anything else? Question mark. Well, we don't have anything here for our constructor definition. In your labs, right, in lab 1, you will have something that specifies the order of parameters, because parameter order matters. Let's just take a look at fields, and let's design something sane based off of these. So, okay, we need parameters. Well, you can't really have a credit card without a customer. So let's take a customer. And you, as we said, can't have a credit card without a bank. Okay. And we're going to need an account number. There's no such thing as a blank credit card, right? Where you've got no account number. What's next? Balance. Balance is interesting. Do we need a balance when we start? Put another way, when you open a credit line, what is the balance on it when it first opens? Some of them are going to charge you something, but that is a charge, right? Hey, opening it is a $20 charge. That's a charge. That's not an initial value. They can waive that charge or increase that charge or decrease that charge. So let's not have a balance. Let's skip that. Right? Our balance will be 0. And then a limit. Yeah, credit limit. Huh. But credit limit. I'll bet you there's a default value for that, right? If I don't specify anything, if I don't have any sort of analysis to go off of, if I've got no risk, no credit score, no nothing, there's probably a default value. It's probably pretty low. And it says, hey, let's, in case of emergency, if nothing's specified, here's the basic thing. So let's do that. Let's say that when in doubt, if nothing else is specified, our limit's going to be $500. That seems reasonable. So we can just say here equals 500. And that will make this parameter what's called an optional parameter. We don't have to specify it. We can give this constructor 3 parameters or 4 parameters. If we don't give it a 4th parameter, it will take this as a default. You can have as many or as few parameters, optional parameters as you want. The only rule is they have to come after all the required parameters. Required parameters come first, optional parameters come second. That's the only rule. Now let's go in. Now we have to create our state. We have to create our object state. And again, I'm going to move this over. Customer bank account balance limit. So cool. And look, they even have the underscore in front of them. So okay. But this won't quite work, will it? Remember, these are just variables. And when, just like a function, when a function is done, these variables go away. Right? If you would like evidence of that, save this, we can run this. And look, it runs. And we can say CC equals credit card. And we look, it shows us our parameters. So our customer is going to be Brian. Our bank is going to be the bank. Our account number is going to be 1, 2, 3, 4, 5, 6. And our limit is going to be $100. Oh, and it helps if you type everything out properly. You need commas between every parameter. Huh. And you can see bank is not defined. Let's give them all dummy values. Okay. Save it, run it again, one more time from the top, and it works. CC is a credit card object, and you can see the memory where it is. And we'll call CC dot underscore customer. And it should say whatever that is, $100 million or whatever. Has no attribute customer. And it's because we never associated these variables with the object, self, right? Remember, self in the constructor becomes this, the object at that memory address. So it becomes that and it gets put into that variable. So if we just put self dot in front, run it again, and call the exact same code, and check to make sure it is still a credit card, and then call customer. Now it's there. But we don't want that there, do we? In fact, that doesn't make any sense. So let's come back in here and let's nuke these and let's set them up. Well, what value do we want to go into our objects customer variable? And I think that this is indented. Real. Oh no, that's fine. Okay. So what do we want to put there? Well, whatever was passed in here. And remember, our arguments map to our parameters. So the first argument maps to the first parameter that isn't self. So we want that Brian will go into cust. So cust, right? Notice that these don't have to have the same name. We'll do the same for bank. And we'll do the same for account. Oh, balance isn't there. Well, what do we do? What do we want our balance to be when we create this object? Oh yeah, that's right. We want it to be 0. 0 is great. So let's do that. 0. And then limit. Well, limit equals 500. Do we do 500 or limit? Well, you know what we'll do? Get rid of that. And let's just see what happens. We'll print our limit. Instead of storing it, we'll just print it. So when we call the constructor now, it spits out the value that we put in, 100. So if we do the exact same call, but hey, limit contains the value 500. Because that's what happens here. This says I need to create a value. I will take whatever's mapped in the 4th parameter slot, but if you don't specify anything, I'm just going to put 500 in there. So this variable still exists. So we can just nuke that, right? We can either delete it or comment it out and uncomment this. And what you see there is a very, very, very common methodology. If you put in code to debug to figure out what's going on, you can just comment it out. I will ignore it. Okay. It's fine if you have something like this left in. It would be bad if you left this turned on, because then your code's going to have unspecified behavior. It's going to start spitting out values that I don't want it to spit out. But you can comment that out. Also notice how I used the program itself to figure out what the program was doing. This is something else that's really good to learn. Hey, I don't know what's actually in there. Let me print it out. Let me see what's going on. Right? Remember, computer science. That's part of the science of computer science. If you're working in chemistry and you go, I wonder what these 2 chemicals do, and you combine them, the best case scenario is that you don't have any eyebrows, right? The worst case scenario is that you make something very toxic. Okay? Doing that with physics, I wonder what happens if I drop this brick off this building, right? Again, best case scenario is property damage. Biology, I mean, you can understand how that could go wrong. So computer scientists need to learn, and developers in general, one of the skills you do need to learn and practice is how to figure out what is going on in your own code and what is going wrong in your code, right? So you need to be willing to try things, right? The rules are you try something, and if that doesn't work, you try something else. If that doesn't work, you try it underwater. And if that doesn't work, you try it on fire. Because unless you are manipulating something persistent, like a file or a database. There's really very little that you can do in a modern programming language that will damage your setup, right? This is working in memory and specifically defined and designed memory. Okay, cool. We're good. Now what? Well, we got all these behaviors to implement. Let's start implementing methods, and we'll start with get customer. So come back in and we'll define. Typically, the coding standard in Python is 2 spaces between methods. Sometimes I do that, sometimes I don't. For compactness on this code, I'm going to skip that. Get. We got our parameters. What's our first parameter? Always. Always, always, always. It's always self. Do we have any other parameters? Well, there are 2 ways to answer this question. The logical way is to say, well, the object already contains the customer. It was defined at construction time. Whatever was passed in, right, has defined an initial customer value. So we got something. The other way to look at it is to look back at the specification and say, hey, look, this thing didn't specify anything. Therefore, I should not have anything here. Cool. Getters do something very specific. They return a value, possibly with light processing. So we're going to have a return statement. We might have other lines of code before this. But what do we need to return? Well, we need to return the customer. Well, where's the customer defined? Self._customer. Remember, it is an aspect of this object. We need self. That's it. That's the list. That's the entire getter. What do we need to do next? Get bank. Huh. Well, we're just going to return the bank value. So we can just say this. Get account is next, then get limit, then get balance. What do you think that's going to look like? Yes. Get. Now remember, this is the name, get account, right? Not get ACCT, not get self.account, it's get account. So whatever is specified in your specification, that's what you need to put here, right? Get account. What you put here is the name of your variable, your instance variable. So if you called it self.acct, that would be self.acct, return self.acct. If you call it self.account, you call it return self.account. And remember, these things are all case sensitive. So that will break. If we run that and we say this, right, we could absolutely directly access this to see what's in there. Hey, it's 100. But if I call cc.getBank, that works great. Get limit, because we have no variable called capital L limit. I know that this seems insane to point out. You will make this mistake. We all make this mistake. This is not a judgment. This is a warning. Cool. Getters are done. Now, none of these do any sort of manipulation of data, but that's okay. Now we need to work on these. So let's work on charge first. Charge is something that makes sense. So let's charge. Okay. Def. Notice that our getters frequently have get in front, but they don't need to. Our setters don't have set in front necessarily, but they could. If we wanted to change the bank, we could say set bank, right? But we don't need to. What's our first parameter? Self, always self. What's our second parameter? Well, the price, right? You will see this sometimes as the name of the parameter. In our labs, it will typically be the type of data, like an int or a str, right? I will specify the type of data that you're going in there. If that's the case, you can name it whatever you want. But again, make sure your names make sense. Cool. So we're going to charge. When we charge something, we add to the price. I'm sorry, we add the price to our balance, right? If we had a $10 balance and we charge a $20 thing, now our balance is $30. So that's easy. Balance equals price and balance plus price. Except that's broken 55 ways. Why? Well, the most obvious is it's not balance, it's self._balance. Okay, that's step one. Notice that price is not that because that's this parameter. Okay. What else is wrong with this? Well, we have a credit limit. What if we had a credit limit of $100 and our balance was $95 and we charged a $10 thing? Well, that wouldn't work, right? We'd go to $105 on our balance and that would be bad. So we could add more code in here. We could say, hey, if price plus self._balance, right? If what will become our new balance is less than or equal to our limit, then do that. Okay, that's good. And by the way, if we were doing this on a lab, this would be pretty close to sufficient. There's one more thing that you should think about, right? Remember, our price is supposed to take a number. Now, I will tell you, in this class, you can assume that when I give you a specification like this, I will be testing it such that I'm giving you at least the right kinds of values, right? So I will give you a number. I will not give you a string. Okay? I will not do that. I will not give you another credit card as the price argument. But what I might do is give you a negative price. Well, I would charge a negative amount, and that means that my balance would go down. That doesn't make any sense either. So maybe I need to add another condition. Hey, only do the charge if my price is greater than 0.0, right? A $0 charge doesn't make any sense either. So if my price is greater than 0.0 and my new balance would be underneath my limit, do this. And we could even add return values if we want to. Return true. Hey, look, it worked. Otherwise, return false. Okay. These two return statements, totally unnecessary. Fine if you put them in. This, if you were doing this code for me for lab or for midterm, this would be sufficient. Okay? Because it meets the specifications. If I said also return whether or not you're successful, then you would need these. Now, like I said, we could put anything in there. So proper protocol would be to check, to do something like, hey, if a uh, only do it if our price is afloat. And you want these to be in order, right? From most general to most specific. This is absolutely appropriate. There's actually a more Pythonic way to do this and a better software engineering way to do it, which is to use what's called an assert statement, right? Hey, I only want to get through this line of code if my price is a float, is a float or maybe an int, right? If it's not, break. And that's literally what assert does. It checks this condition. If that condition's true, it keeps going. If not, it raises an assert exception. Let's see. Does that run? Yeah, cool. cc.charge, $10. cc.get balance. Hey, look at that. cc.charge, all those bucks. Get balance. cc.charge. I'm going to charge a potato. Insertion error. Okay. In reality, you should be doing things like this. You should not be getting to the business logic of your method without checking information. I am not going to enforce that in this class. You have enough things to worry about without doing a super anal job of making sure that all of your code is designed perfectly and checking all sorts of inputs. And I will tell you, if you can think of it this way, like this is a big process in itself. If you have a very lightweight object that is designed to take information, hold information, and then spit that information back out, but it's designed to be general purpose, the error checking can be the majority of the code in your object. So this is a good practice to get into, but is not necessarily required in this class, okay? You can assume when I tell you, hey, this is the kind of value I will give you, that I will at least play by those rules. Now, the value might not be within the logical specification, but it will at least be a number, right? This string will contain the user's last name. I promise you, I will give you a string. It might be an empty string, right? Or it might not be alphanumeric or alphabetical rather, but it will at least be a string. Hey, we got our charge. We can just, because our make payment is not terribly different, is it? Our make payment, hey, we got to change our amount. Hey, we're going to pay that amount. And now we're going to substitute this in, right? This still needs to be a float or an int. Is it greater than 0? Yeah, we want to take a payment amount that is not 0. A payment of 0 makes no sense, and a negative payment doesn't make any sense either. Right? But then we want to say, okay, do we want this to be the relationship? No, not really, right? We want to say, hey, I've got a balance of $50. I want to pay all $50 off, or I want to pay $25 off. But if I pay $100 off, then the credit card owes me money. So we shouldn't allow that. So let's say, and our amount is less than or equal to our balance. or our get balance. We can do that too, right? We can call the method, and this will then return this, right? Hand off to the method responsible for getting the balance what that means. That way, if there's any coding or any math or anything like that, it does it. And then we can say, cool. Instead of adding to our balance, we can subtract our balance. Now, this is the fact that we could reuse most of that code is a quirk of the object that we're defining. But there's nothing wrong with that. There's nothing wrong with going, oh, this is going to be very similar. I mean, it's logically different, but it's structurally similar. Let's just use that and then change as we need to. There's nothing wrong with that. Also note that we can substitute our get balance on this side, right? Because this is informational. But we can't do it on this side. There is no way to set the balance through a publicly visible method. The only way is internal, right? We are controlling that because Lord knows if you could set the balance of your credit card, I know what I would set mine to. Okay? But now this runs and we can give it and we can say cc.charge 150 cc.get balance, right? cc dot make payment 5, and we can do this a few times. We can make sure that it works, and then maybe we can do make payment 125. Make sure that nothing changes, or we can do exactly 75. Make sure it works. Okay. This is an important part of the process. I will be providing you tester files for the labs, and that's going to be helping you in robustly testing your code. But you should be doing this testing as you go. You should not be waiting until the end to test your code like I did here and all up here. Okay? If you wait until the end, then you've got no idea where your code has gone wrong. But if you test your accessor methods, your getters, after you implement them, and then you do something else, and then you call, you create a new method, you create your get balance, and all of a sudden your get balance doesn't, you call charge, let's say, and all of a sudden your get balance doesn't work, then you know what's happening isn't that your get balance is wrong. It means that your charge did something wrong. And you broke it in your charge, and at least now you've got a place to start. You got a place to look.